So again, if you look in the description down below, you can find the index, or you can find the index to these meetings. We got like 3 years worth of index. The HTML file is fairly well organized, and you can just either click on the image or the link, and it'll take it out if you want to watch the video, so that you can go back through history and search it for, say, radios and GPS or whatever you want. So that's there. I should have given a little more thought here. We backed up the Slack stuff, and that goes back to day one of like January of 2020. No, January 2021, I think is when it starts. And I've got that all out on the on my web page, and I need to start adding that into the description at the bottom too. So anyway, by using the index and the Slack backup and the YouTube video page, you can tie this stuff together and see what's going on there. So other than that, I didn't get anything done, and I'll just turn it over to Al. He's got some interesting stuff he's doing here.
He says interesting. Let's see, where's the share button? I always have to find that. So a few posts that I've made out on Slack, I'll just walk through those because that's sort of like the breadcrumbs of progress that I've made. Backing up at a little bit of a high level, there's a guy who has created a PCB board for his radio control, and I'm trying to not copy exactly, but create something that's similar to what he's done. And this is his physical outline of his PCB board, and it's sort of nice that you can hold it. And he's using a Nano. I'm trying to use a Teensy. He uses the NRF24, which I'm using. He uses two joystick thumb things. I'm not doing that. I was going to use just a simple potentiometer on the left and the right side. But anyway, that's one of the things that I've been sort of trying to follow. In that regard, I wanted some LEDs to be able to show some status on the radio control, and I ended up getting these RGB LEDs from MPJA, and I thought they were going to be exactly the same as using the Adafruit RGB LEDs that come in the little square SMDs, but these are through-hole LEDs, and they're not exactly the same. So that was I think I just stumbled across the fact that literally in one statement, instead of saying with the Adafruit, you would use GRB, and then with these MPJA LEDs, you use RGB. Wow, was that a pain in the butt to try to find. But anyway,
On a related note to that, it turns out if you order the individual LEDs like this from Adafruit, they work the same way. So it turns out they are the same. They list two different control chips that don't match this one, but those that look like real LEDs, and they're the addressable ones, they act just like these, where it's got the colors reversed on it. And the other thing is, I went out to Amazon to look for these, and it turns out that MPGA seems to have these at a fraction of the price anybody else out in the world has. Even if you go out and buy, say, 10 or 100 on Amazon, they still have from what I can tell, this is the cheapest price. It was like 10 for $2.95. But you have to pay they have a standard, not their shipping is gonna, I think, to $8 for anything you buy. So if you need to stock up on things, dig through their page and find a bunch of stuff to buy to make up for your $8 shipping. But those do seem to be, it turned out, I was surprised that they do have the cheapest price. You can't just go to Amazon or eBay and get something cheaper. So that's something to consider. And I noticed that right on the Adafruit page, when I found these individual LEDs like this, it says right in the code there, it says, oh, by the way, these have the colors reversed. So they're basically, these work just like if you buy these from Adafruit instead. They all seem to, apparently they all seem to work the same way.
It's it's and for me, I'm having to test it on my proto board here because I don't want to like order the PCB and it not work. So I'm just sort of double checking that everything works on the proto board before I finalize it. Then using these, I also have to, because I'm using the Teensy, put this level shifter in here to deal with the fact that the Teensy is at a 3.3 logic level and these things want the 5-volt logic level. So that's been, and it worked. It's the first time I got a level shifter to work. Previous attempts were miserable. So I was obviously doing something wrong, but this time I've got it to work. So that's pretty cool. And there's some code out here that you could use. Oh, the other thing about the code is because I'm using a Teensy, I stumbled across it. Teensy has this built-in function, elapsed millis. You have to, I'll call it the traditional world, you capture the current time and can calculate the elapsed time and compare that to your timer setting. But using this function on the Teensy is certainly more elegant than that. So that was a new find as well. Also, using this, I'll call it an array. It's probably not actually called an array in C code, but I could set different colors. And the reason I did that is I was testing what do I actually want to use as yellow, because I think golden is more yellowish for my eyes anyway than these others. That's why those were different. Why I had different colors in and around that space as I wanted to test to see which one I wanted to use for yellow. What else did I mention in? Oh, so after I got the LEDs to work, I've got an on-off toggle switch and wanted to make sure all of that was going to work and put it in some sort of loop so that it was running. So my loop was very simple, right? So this is my code, and that's all the loop is. It's just calling these functions: read the radio, update the LED, update the switch LED, update the blink LED, print some stats, and then the functions are all up here. And this is what that timer looks like. I mean, this has got a hard-coded, obviously 10-second interval, but that's the simple loop that runs. I'm not going to go through all this code, but it just allowed me to have different timers. And on the update switch, let's see, when I'm running my radio control, I have a mode, what I'll call a mode switch. So it's either in manual mode or automatic mode, or I might put it in pause mode. And the way I get those three settings off one analog switch is, I'll show you in a second what the hardware looks like using resistors on two digital lines to get those different states. But then I set a different color, and so I was just practicing setting the different color based on the mode switch of those digital pins. I don't think there's anything other. I mean, we've talked about the NRF radio before, so let's go back to Slack. That code is out there on GIST. And then, yeah, so I posted a PDF of the current wiring diagram, but let me show you the actual wiring diagram. I go back to this online tool called EasyEDA, which lets you sort of lay out the wiring, and then it'll do the physical wiring on the PCB and let you clean that up before you actually order it. And then it, you know, it has an easy ordering function as well. But I was mentioning these resistors. This is putting those two 10K resistors on the data lines and feeding the switch 3 volts. I'm able to get that high and low state on those two digital pins. Here's the NRF with all of its wiring. Here's the level shifter, which the feeding the data pin over here for the LEDs. In this particular case, I've put 4 LEDs in the board. Jeff made a wonderful suggestion to carry that out to another pin in case I wanted to further daisy chain more LEDs, toggle switch. I was going to have a battery hooked up here, toggle switch to turn, you know, the power off and on so the battery doesn't drain. Steering and throttle potentiometer, and then I was just going to put a couple more potentiometers on the board, or at least the wiring there. If I flick over to my Miro board for a second, this was the layout that the guy I'm following, I mean, this is his sort of logical layout. It's not the actual PCB, but I like that graphic, so I included it. But anyway, that's what my physical toggle switch looks like. That's what my physical potentiometer looks like. I was just cutting and pasting some of this stuff on my Miro board for reference. That's what the level shifter, about $1 a piece, 80 cents a piece. I was going to use two 18650 batteries, so, and then use the 7805 for taking the plus or minus 8 volts out of the two 18650s and get it down to 5 volts and feed that 5 volts into the Teensy on the VIN pin. So that's sort of what that's looking like at the moment.
So while you got your schematic up there, I was noticing that that toggle switch, you've got 2 resistors you placed on there. And I'm thinking, well, you could have used the internal pull-ups in the processor, although sometimes you might be better off like doing a switch, maybe putting the external resistors. Then I notice it's wired. Those are actually pulled down resistors, not pull up resistors. You can do it either way. But the point was, then I look at the bottom, you've got your push buttons and you don't have any pull ups or pull downs on those. So at least remember to turn on the internal pull up if you're going to use, to read those push buttons there. What's that black line?
Ground.
Okay, yeah. So you have to have a pull up one way or the other. Either turn on the internal pull ups, and if you find out there's any noise or something there, you could put a resistor. You could put patterns down for resistors and just don't put the resistor on the board. That's another clever thing to do as you work along here. Do things like that.
Yeah, I've jumped over to my Arduino IDE, and just for testing, that's what my pin mode statement looks like, just to test it out. That's actually what I was doing earlier this morning. So I don't know how correct that is. You're a better programmer than me. To be clear. So that's just what I was doing.
So on your toggle switch, are you doing the same? Are you using the pull-ups on your toggle switch, and then you have extra pull-down resistors?
I don't
Or what
remember. I'd have to pull up the code. Let's see.
Because I would say if you're going to have the pull-down resistors, do not turn on the pull-up in the code.
Let's see, pin 3 and 4. Come on. Ugh. It's in my way. Something's in my way. Can I move it? I can move it. Looks like I did.
Because there you've got two things fighting if you're doing that. You got one trying to pull it up and one trying to pull it down. And that may cause problems and you won't know why. So because if you have pulled down resistors on those inputs, that's going to keep it at 0 volts. And then when you flip the switch, you're putting actual 3.3 volts into that pin. So that's the way you want it to work. You don't want the pull up, because now you've got a pull up and a pull down in parallel all the time on these things. So at least for those two pins, do not say input pull up. You just want them as regular digital inputs.
Okay. Yeah, I'll have to test that. I was getting behavior that I was expecting, but then again, I wasn't. It's worth certainly going back and testing that. So drop that. If I'm going to do it with hardware, take that out, is what you're saying.
Yes.
Okay.
And just another minor note there, you could have wired your switch so that the common coming into it is ground, and then the other two pins are going to go to your input pins. You could put pull-ups on those or use the internal pull-up to do that. So
Yeah,
again, you can wire it one way or the other. It's just you have to pay attention to what you're doing.
yeah, I definitely tried it that way, and I probably messed something else up, because that's what I started with, is a ground over here, and couldn't get it to behave the way I wanted it to. But anyway, I can go back and give that some more attention.
But if it's working the way you want it right now, you don't have to change anything. It looks like that will work. It's just that do not turn on the internal pull-up if you got those things pulling down externally.
Yeah, I would rather be consistent, so I'll go back and see if I can get the ground to common to work. What else was I going to mention on this? Oh, again, back to the Miro board. That's the potentiometer, and it shows 4 pins there, and I've tested that, and I can't. It just looks like it's a dummy. Went to the data sheet, and they had one model that says that's a dummy, and another data sheet that really didn't seem to clarify what that 4th pin was for, but I think it's just a dummy on the model that I bought. Yeah, I think that's where I've gotten to so far, following this guy's tutorial. Well, example. EasyEDA is nice, but I found that if I change one thing on here and then I convert schematic to PCB, it all starts over. And so any work that I've done to lay out this design, I lose. So that's been a bit of something to deal with, but I'll get there slowly but surely, as with most things with me.
And I don't know if we mentioned this while we're recording, but earlier I was pointing out that if you put on a pattern for both radios, that way you just pop out one radio and put the other one in. So if you decide for some reason you don't like this radio and you want to go back to LORA stuff, you just unplug one and plug the other one back in. So that would be something to consider on that. When you're making boards like this, if you put enough, extra flexibility in that you don't have to go rewire everything. And speaking of that type of thing, that 74, what is it, ACT 125, you're only using one channel. It's a 4-channel device.
Right.
If that were a surface mount part, it would be good to bring the unused pins out to just pads. So if you ever want to, you need one more channel of level translation, you have something you can solder to. Being a through hole part, it's not that big a deal because you can just flip the board over and you got enough space on the back. You can solder wires onto the pins that, they're not being used for anything, but they're on the board and you can solder to them. But, things like that where you go to build the PC board and you've got some unused pins. Like say right now I'm just glancing over at your Teensy there. You've got some unused pins sticking out there. You might want to put pads there next to those, just so if you decide you want to, you can just solder a wire into a pad there and run it somewhere else on the board, whatever you can use it for. Now, again, since the Teensy looks like a through hole part, you can always flip the board over and you can get to the pins on the back and just solder right onto those. It's more important if you got like little surface mount parts and you later decide you want something. They got the little tiny pins you'd have to solder onto if you wanted to use extra pins that aren't hooked up right now.
Yeah, until your comments, the only sort of expansion that I had built in was like these two push buttons I don't have a particular use for at the moment, and these two potentiometers I don't have a particular use for. So I think you're giving me good advice on how to make it easier for other expansion as well. Because as you can see, you're right, I didn't bring anything else out from that level shifter, just those three. Cool. It's easier when it's in software than when you start printing hardware.
Battery connector, is that a keyed connector so you can't plug that in backwards?
I don't know. I chose the library item that I chose was this JST 2-pin. I think I could physically mount. I'm assuming that this is going to be 2.5 millimeter separation, so I could. That's the only physical connection, as opposed to some other pin. I could make it, I'm hoping, or whatever I want, but I don't know. To answer your question, it's whatever I've chosen here, and that's just a generic JST 2-pin connector.
So do you have the option as you're going through this whole process, can you just print out the actual traces on a printer so you can go back and look at it? You can go back and measure the pin to make sure that the pin spacing is what you think it's going to be. Because you really have the two standards. You got the 10th inch spacing and you got the whatever the metric spacing is. And I was thinking the JST connectors are different than standard 10th inch spacing. So that's something to keep in mind, that as long as it's just two holes on the board, you can solder anything you want in there as long as it will fit. So you just want to make sure that say if you're going to buy a battery, it's got a connector on it already. You want to make sure that whatever that connector is, it'll fit on whatever you solder onto the board.
Yeah, I'm just looking at the export function. I haven't tried it, so I don't know is the answer to your question, but it appears that I could put it either in a PDF or an SVG file, and if I do it in SGV, I could pull it up in like Fusion 360 and get down into measuring it. But let's just.
Actually, that thing right there where it's got the grid on there, when you go to place your parts, you should be able to see if the pins of the connector are falling onto that grid, because that looks like a 10th inch grid. But right now you just got two devices shown on this thing. But so if you put your connector down, place it onto this layout you got here, you can see if the pins fall onto the 10th inch spacing or not.
Yeah, so the grid, I've got something in my way I can't see. This is showing you can see my screen, right?
Yes.
So this is showing a grid size of 2.54. If you zoom in on Teensy pin 10 and Teensy pin 11, I don't know if you can, there is a line running right through those, so that showing the spacing. If I were to pull over that JST connector, I'd be able to see if it's exactly the 2.54 spacing. That's what you're talking about, right?
Yes. And we know the Teensy and the radio are on 10th inch centers, so that tells us that 2.54 millimeters is a tenth of an inch because they
Oh,
are falling on the lines there.
I'd never called it a tenth of an inch center. I just called it a 2.54 center. That's interesting. Um, so it's a powerful tool. It's got some persnickety issues with it, but yeah. And then I've changed that. You can change the grid size. I changed it to 1 millimeter somewhere else because I was trying to figure out these dimensions. It was a pain in the backside. The issue is if I change this and then go back and add a part to the board and then rerun the generate PCB, I lose any of the shaping that I've done. So that's why.
You might be able to create that outline as a part. So say I want to build a part and then draw the line, and then just when you place it on the board, that would be a part that would stay there. So it shouldn't disappear then each time you rerun it.
No doubt there's a more elegant way to do it than I've done it. So I'll look at that. But I couldn't find any YouTube videos on people who actually created special shapes like that. But
And I've never tried that, so I don't know what all the details on that are. So
it's super cool if you can get it to do what you want it to do.
yep.
But that's where I'm at that at the moment. I mean, this little slider switch is not very robust, but it'll do me for right now.
So when you draw that pattern around the outside, is that going to be considered the board outline? You know, in their terms, you're assuming that it's going to be cut around there.
This board, no, this is just consider this like the bill of material and the connections.
No, back to that picture you just had where you're saying you're drawing that outline. That's what you want the board to look like. Do
Yes.
you somewhere in there tell it that is the board outline, and then you're assuming they're going to cut it on that?
Yeah. So this, I am definitely assuming, and based on history, can confirm you're going to get a board that is that outline.
And some of the times when you get these made, you have to put little tabs around there so it doesn't actually cut it out completely. It just leaves these little tabs that you have to snap out later. And I don't know. Again, if you watch your tutorials, especially go back to the guy that did this originally and see if he says anything about, how you have to create that, or, if you have to specify anything as you order the thing. It could be if you just call it the board outline, they're smart enough. They know how to, there's stuff will say, oh, that's the outline. I'll put these little tabs in for you or whatever. I don't know. I don't know how that's going to work.
Yeah, they always break them apart. So they send me, EasyEDA doesn't, but then this goes to, the Gerber files go to PCB Way or one of those guys. And they separate them out. It's not like I get one big sheet with 10 pieces in it. So somebody over there is sort of laying this out and putting in those tabs that I'm thinking of when you talk about tabs, because I get the individual boards.
Yeah. It's just when they go to cut it out, they put this big panel on the machine. They got a router that goes around and routes the whole thing out. They don't want it popping out, becoming loose while they're doing that. So they have to do something to,
Keep it all as one.
yeah.
Yeah, that's all part of the magic behind the scenes. So I don't know anything how they do that. But this is, I'm assuming you can see this
Yeah.
legend. Whatever this board outline is what I'm expecting to get, the actual PCB material back as.
Okay.
That's it for me. Other than now, I got to go back and test my pull-ups. And I'm not talking about chin-ups. I'm talking about resistors.
Uh-huh. Okay, I don't think I have anything either.